Hopefully you've had an opportunity to try these practice problems. I'm now going to walk through the solution. So if you haven't done them, pause, give them a try first, and then watch the rest of this video. So I'm just going to go through these and I'm going to do it the way that I've been doing it. So I'm going to start with A. So A is going to have 3 carbon. If I can get this working. It's going to have 6 hydrogen. Each of these have 1 valence electron. Each of my carbon have 4 valence electrons. And I'm going to have 2 fluorines. And fluorine is a halogen, so it has 7 valence electrons. I'm going to go through and decide how many bonds I'm going to need for each of these. So for my carbon, I'm going to need 4 to get to an octet, since I only have 4. Each of my hydrogens will just need 1 bond, and each of my fluorines will need 1 bond as well. That makes my carbon the one that needs the most bonds. So I'm going to start with that in the center. But I've got 3 of them. So now I need to arrange 3 of these. Actually, I'm going to go down here. I'm not very creative, so I tend to just link these up. So I'll put my next carbon, making sure that each of these has 4 valence electrons, like that. And I can see right away that I've created single bonds between each of these carbons by bringing those 2 electrons together. All right, now at this point, I'm going to count up the number of unpaired electrons I have. 1, 2, 3, 4, 5, 6, 7, 8. All right, I have 8 unpaired electrons. And I have 6 hydrogen and 2 fluorine. And that means I've got 8 atoms that just need 1 bond. So these match up perfectly, so I'll have all single bonds. So now I can come in and arrange my hydrogens and fluorines so they match up to these unpaired electrons in any order I want. And that order will have an influence on the reactivity of the molecule and the polarity of it. But in terms of building a reasonable Lewis dot structure, it won't matter at all. And there'll be lots of slightly different answers to this problem because of that. So I'm going to put my fluorines on the end because I guess just a whim on each side. And be sure to draw the lone pairs on this. That's really important. And so I've created a bond between these fluorines and carbons. Next, I'm going to place my hydrogens. 1, 2, 3, 4, 5, 6. And I've created bonds there as well. And so now I can redraw this in one of 2 ways. So I'll have my fluorine. And I could do it with lines to represent each bond. That's my personal preference because it allows me to see the lone pairs kind of stand out. I find the dots of the Lewis structures that are all electrons a little bit visually overstimulating. But if they work for you, that's great. So those ones would look like this. So I've got my lone pairs still on my fluorine. And then I put my 2 electrons that are shared in between the fluorine and the carbon. And so I'm just going around replicating this. And I put the dots side by side with one another as a convention that chemists do. If you want to keep it the way I have above, where it looks more like the puzzle pieces and the connect the dots strategy, that's fine with me. You might run into teachers later on that think it's weird, but it works. All right, so that's A. All right, I cleaned up our page to make a little bit more room, but left our solution for A up here. So now let's look at B and work through that. And we'll kind of do the same thing, then I'll clean it up and move the solution up over here. So for B, we have 2 carbon with 4 electrons each. We're going to have 4 hydrogens this time, and we're going to have 2 oxygens. And oxygen has 6 valence electrons, so it's going to have those 6 dots around our oxygen. So in terms of the number of bonds that each one is going to form, that carbon's going to form 4, our hydrogen will form 1, and our oxygen with 6 valence electrons needs just 2 more to get to 8. So it'll form 2 bonds. All right. So with that, I'm going to go ahead and start building this structure. So my carbon has the most bonds again that it needs. So I'm going to put it in the middle. And I have 2 of them. So I'm going to just put them side by side. And that creates a bond in between them, one single bond. Now my oxygen needs 2 bonds, hydrogen 1. So the next one I place that needs the most is oxygen. And where you place these is up to you. There is something to be said for putting them on different carbons, but you could put them on the same one. In any Lewis dot structure strategy, you might find that you have built yourself into a corner where you can't finish the structure in a way that everything gets an octet. Sometimes you just erase and start over. I am going to throw my oxygens on opposite sides. Why not? Again, there's lots of solutions here, not just one. So that's okay. All right, so I've created a bond between each of these carbons and oxygens. Now I have 4 hydrogens left to place. So let's count up my unpaired electrons. 1, 2, 3, 4, 5, 6. Okay, so I have 6 unpaired electrons right now. And I have only 4 atoms that need 1 bond. Looking at the difference between this two, this leaves 2 electrons that need to be in multiple bonds. So I need to pair up 2 electrons, and I have a choice. I have lots of choices. I can pair it up between one of the oxygens and carbons, between the 2 carbons, kind of go any way. It doesn't actually matter, at least for making a reasonable structure. I'm going to go with 2 of the carbons. Why not? So I'm going to pair those 2 up in a double bond, and then I'm going to place my 4 hydrogens. And I'm going to place a hydrogen at each of these unpaired electrons. And I'm going to now kind of redraw my structure so it's a little easier to see. And I'm going to use the lines because that's my personal preference, but you can also use the 2 dots to replace a line. That is just fine. So here I have hydrogen bonded to an oxygen with 2 lone pairs. It's very important to keep the lone pairs, and that'll become apparent when we start working on Vesper theory. I have a carbon, and it has 2 bonds between the carbons because I paired up 4 electrons. These 2 are forming a bond, and these 2 are forming a bond. And both of these carbons have 1 hydrogen and 1 oxygen bonded to it. And each oxygen is bonded to a hydrogen. So looking at this structure, all of my hydrogens have 2 electrons. Each carbon now has, I'll show you in the count in this one. 1, 2, 3, 4, 5, 6, 7, 8. Each of my oxygens have 1, 2, 3, 4, 5, 6, 7, 8. So I've satisfied my octet rule. So this is a reasonable structure. All right, now I'm going to clear this up and get ready for C. Okay, now we're going to look at C. So for C, we again have 2 of our carbons. So let's do this. These each have 4 valence electrons, so I'm putting 4 electrons around my carbon. I've got 3 hydrogens. They each have 1 valence electron, and I have 1 nitrogen, and that has 5 valence electrons. So looking at the number of bonds I'm going to need, that carbon's going to need 4, each hydrogen's going to need 1, and the nitrogen is going to need 3 bonds to fill its octet rule. So carbon has the most, so I'm going to start with that in my center. So I've got my carbon, and I have 2 of these, so I'm just going to link them up. Again, not being super creative and not really trying to be. And then after that, I have my next most bonds that I need is for my nitrogen. So I would place that next. I just have 1 of them, so I'm just going to place it here on the end, creating a single bond between that carbon and the nitrogen. Now I have 3 hydrogen, and let's count how many unpaired electrons I have. I have 1, 2, 3, 4, 5, 6, 7. Ooh, I've got a lot. I have 7 unpaired electrons, and I have only 3 atoms that need 1 bond. That leaves a difference of 4 electrons that need to be in multiple bonds. Okay, so that means I have to pair up 4 of these electrons that are unpaired now. And I can do this a couple ways. Let's see. I know we've already seen the pattern where we had a triple bond between the carbon and the nitrogen, so let's do something different. Let's pair up these electrons here on the carbon. So I've taken 4 electrons and paired them up to make 2 more bonds. Now that leaves me with only, look at that, 3, they're highlighted in yellow, 3 unpaired electrons. Now that's where my hydrogens can go because I've got 3 hydrogens. So let's place those. I just line them up. So 1 can bond to the nitrogen and 2 can form bonds. Sorry, 1 can bond to the carbon, 2 can bond to the nitrogen. All right, I'm gonna like make this look better with the lines. Again, you can also do it with the 2 dots. So I'm gonna have a hydrogen bonded to a carbon, and with 6 electrons shared between these 2 carbons, I have a triple bond. And then I have a single bond to my nitrogen with its lone pair that I'm gonna include, and its bonds to hydrogen. And again, you could have a double bond between the carbons and a double bond between carbon and nitrogen. You could have a triple bond between the carbons and the nitrogen. There's a lot of different ways you could do this and still have a perfectly reasonable structure. I'm going to clean this up and then we'll do our last one, which is going to be a polyatomic ion. All right, last one, D. So here we have a polyatomic ion. And we have a positive one. It's a cation. So we have a cation. So it means we're going to remove 1 electron. And which one it is, I'm not sure till I kind of get started with my structure. And so whenever I have one that's just in the way, I'm just going to delete it, basically. So I have, in this one, I have 3 hydrogens, each with 1 electron. And I have 1 oxygen that has 6 valence electrons. So I've got my element symbols here. So the bonds that I'm going to need, each hydrogen is going to need 1 bond to reach the duet rule. And my oxygen is going to need 2 bonds to form a octet. So that makes my oxygen the one with more bonds that it needs. So I'm going to start with it in the center. And I am going to start placing my hydrogen atoms because I only have these 2 elements. So I'll place a hydrogen at each of these unpaired electrons. I'm like, great, this is going fantastic. I've made water. I have an octet around oxygen. I have duets around my hydrogen. And it'd be nice to be done, except I have 3 hydrogen I have to place, and I need to remove an electron from somewhere. So I'm going to take away one of these oxygen electrons, and I'm just going to delete it. And so that means I'm going to highlight it over here on the oxygen element symbol. This is the one that I actually ended up removing. And then I'll be able to come in and add another hydrogen right here and form that 3rd bond. Now, because I removed an electron, I am going to put brackets around this and a positive symbol. So I remember that I had to remove an electron to make this structure work. And it means that it has an overall positive charge and it can participate in ionic bonds now. So if I wanted to draw this with just lines, it would be a hydrogen single bonded to the oxygen, and there'd be 3 of those. There's still a lone pair on the oxygen, and I will keep brackets around it and a positive charge. Now, just because you'll see me do this shorthand later, this bracket I sometimes abbreviate with just the corner of the bracket by the charge. And it looks like a giant 7, and it's not. It's just the corner of the bracket to abbreviate it. And it's really just a laziness thing. All right, so hopefully these made sense. If not, I would say run to your textbook and do some more practice problems or ask me for some more. Yeah, good luck.